Sometimes in your mathematical career, you may be asked to find a required sample size to construct a one-mean confidence interval, particularly if it has a specified margin of error. So to do that, you can start with this formula for margin of error, which is t star times s over root n. It might also be z star times sigma over root n, but it works the same way. Now just do some algebra and get n equals t star times s over me squared. So let's suppose someone asks you to find the sample size necessary to find a margin of error of 5 units for a variable with sigma equals 11 at 95% confidence. So one thing to note here is if they're giving you sigma, that means use z star and the normal model. Since we're using the normal model in z star, the formula turns into this. Now we just put in the numbers. At 95% confidence, z star is 1.96. Sigma is equal to 11. The margin of error requested was 5. Take that all, square it, and we get n is greater than 18.593344. Over here I wrote equals, but it's probably makes more sense as greater than because you can't actually have 18.59 observations. So what you do is you round up, and we conclude we need at least 19 observations. So another tip that would be useful is to always use exactly 3 decimal places for z star or t star. In this case, I used 1.96, but it is actually 1.960, so I just didn't write the last one. But that's pretty much it. Put the numbers you're given into this formula if they give you sigma, this formula if they don't. Although, now that I think about it, how are you going to find t star if you don't know n, because degrees of freedom is n minus 1? So I think you always have to be given sigma, so I think this is the formula you're always going to use. But whatever.